All right, guys, today we are going to start off doing just a few more examples together, and then you're going to practice a ton of what we call one-step equations. And as we go through the examples, I will explain to you why they're called that if you haven't quite figured it out yet. And you'll see how this is really just taking the things that we've done on Monday and Tuesday and combining them and making sure that we can do both types when I mix them all up. So what do you need right now? You need a piece of paper. You of course need pens, pencils, whatever else. We're going to start folding this paper. All right, watch closely as I fold this because we're going to do it just slightly differently than we've done it before. We're going to start off the way that we often do by folding it in half this direction. Get a nice, good crease there because we need to be able to see them. Then I'm going to fold it this direction. Get a nice crease there. Okay, then we're going to fold again this way. And I think that we know by now that this gives us 16 boxes. We actually need double that, so we need to fold our paper just one more time, which can get a little tricky. So maybe before we do that, let's use my pen here to really flatten this out. Okay, and then I'm going to go one more time this way. You ready? I want this way instead of these, like, I don't want that super skinny way. I want this way. Really press that crease as good as you can. Flatten that out. Use your folding muscles. That's a thing, right? Folding muscles? I don't know. And then we're going to open it up. Okay, to start, we're going to do some of these problems together to really make sure we have down this whole solving one-step equations thing. In fact, we are going to write on the top of this paper. I'm going to write up here, solving. I'm left-handed. My pen doesn't like to write in that corner very well. Solving one-step equations. Just going to put it up in a little box like this. So it's my title. Okay. And then I'm going to write in these first few boxes, I'm going to call them examples. Okay. So they won't be confused with what you're going to do on your quizzes practice. So I'm going to call this, I'm just going to put underneath that example 1, circle it. In this box, I'm going to put example 2. You can't see my fold very well, but there is a fold right there separating the boxes. Then I'm going to come up here and write example 3 and example 4. And we'll do some more examples together, but I'm going to write these ones down first, okay? I'm going to change colors just because. I'm going to write my original equation in purple. So I'm going to give you 4 equations that I want you to solve, and they're going to look very similar, but they'll actually be really different. So I am going to first write x plus 5 equals, just kidding, I didn't mean to write that. X plus 5 equals 20. That's what I meant to write. Example 2, and we can cut that, got a little squishy, so I'm going to come down here. Example 2 is going to be x minus 5 equals 20. Example 3 is going to be, let's do 5x equals 20. And example 4 is going to be x over 5 equals 20. These equations all look quite similar. They all have an x, they all have a 5 in them, and they all have a 20, and they all have, of course, an equal sign. But changing that operation, and here's my crease right here. You can see your crease. You can trace over them if you want to, but I want to make sure I can just write my inverse step and write my answer without going over that line because I need these other boxes. So let's just go through these 4 and let's make sure when I start mixing them up, meaning you've got addition, subtraction, multiplication, and division in all these one-step equations. Can you keep them all straight in your head? Can you isolate the variable correctly? Can you show me the inverse step? And can you get the correct solution? So let's try these 4 together. I'm switching to this bright green color here. I still am going to go through this process every single time. Here's the variable over here on the add line side. What are they doing to the variable? Think that to yourself. Okay, if they're adding 5, what are you going to do? You are going to subtract 5, right? Your goal here, because it was addition, you are trying to turn it into 0. Addition and subtraction, the inverse operation you want is whatever turns it into 0. Whatever I do to the add line side, I also need to do to the Penelope side. So I just did minus 5 because I'm doing the additive inverse here. Additive inverse, turn it to 0. That's exactly what happened here, because now I have x plus 0, which doesn't get rid of the x, it just makes it x, right? So now I have x equals, do the math on the Penelope side, x equals 15. Okay, example 2. How is this one different? Well, the variable is still on the add line side, but this time what they are doing to the variable is they are subtracting 5. So what are you going to do? You are going to add 5. You just added 5 to one side, so now you absolutely need to add 5 to the other side. If you start with a different operation, it affects how you solve this, and it affects what your answer will be. You still are turning something to 0 though, because additive inverse is turn it to 0. All right, then x equals 25. Very similar equation, but very different answer. Let's look at example 3. Okay, the variable is still over here on the add line side. What are they doing to the variable? Oh, they're multiplying by 5 this time. Now I have to shift my brain away from additive inverse over to multiplicative inverse. So on these two, I was trying to turn the number with the variable into 0. On these two, I'm going to try and turn the number with the variable into a 1. Because now we're multiplying and dividing. Keep those inverse operations straight. Adding and subtracting, turn it to 0. Multiplying and dividing, turn it into 1. All right, so if they're multiplying by 5, I'm going to divide by 5. And I'm going to come over here and divide by 5 as well, because whatever I do to the add line side, I of course have to do to the Penelope side. That turns into 1. 5 divided by 5 is 1, and I get x equals 4. Over here, what are they doing to the variable? They are dividing by 5. So we are going to do the inverse, which is multiplying by 5. I wrote it on the top because I know I'm trying to turn it into 1. Whatever I do to one side, I'm going to do to the other side. 5 divided by 5 is 1. X equals 100. So those 4 equations looked very similar, but they came out with very different answers. Because if all you do is change the operation in your equation, then you have to change the operation you do to solve it. And let's plug these in and make sure they make sense. Yes, 15 plus 5 equals 20. 25 minus 5 equals 20. 5 times 4 equals 20. And 100 divided by 5 equals 20. Okay, we're going to do 4 more examples together, and then I'm going to show you what I want you to do with the rest of this paper. Okay, so come down to your next crease of your boxes, which mine is right here. And we're going to write example 5, example 6, example 7, and example 8. Okay, I'm going to give you 4 more equations that look really similar but are going to end up really different. And I'm going to make them a little more complicated with some negatives and stuff. Okay, so I'm going to do this one. Let's say negative 14 equals negative 7 plus x. And then I'm going to do negative 14 equals 7 plus x. And then I'm going to do negative 14 equals negative 7x. Then I'm going to get really crazy on this one. Are you ready? Negative 14 equals negative 1/7 x. What? Okay, so again, these look really, really similar. Here I go. I'm going to take you through a think aloud, and we're going to solve all 4 of these. You're going to show your inverse step, and you're going to get a solution. The variable is on the Penelope side. They are adding a negative 7. I want to turn that into 0 because it's addition, so it's all about additive inverse. Well, a negative 7 turns into 0 if you do a positive 7. So I'm going to go plus 7. Yes, technically I'm subtracting a negative 7. This is the quicker, easier way to do that. I just did something to the Penelope side, so I also need to do it to the Adeline side. I'm gonna watch my signs here. Different signs subtract. Take the sign of the one that goes farther. Okay, and then I'm just gonna flip my equation around so that my answer looks right. I just solved this equation, x equals -7. Example 6. Hey, I still am over here on the Penelope side. I'm still doing addition, so I'm going to turn it to 0, but this time it's a +7, so I'm going to go -7 or -7, additive inverse, turn it to 0. I need to do the exact same thing on the Adeline side. So this one turns to 0. This one, now I do the math over here, same signs, add, keep the common sign. All those rules we learned in the NS strand last term absolutely come back in a big way here. X equals -21. Let's stop real quick and see if those make sense. Is -14 equal to -7 plus -7? Yeah. Is -14 equal to 7 plus -21? Yeah. Now look right here. These are the ones we sometimes get tricked on. What are they doing to the variable now? Now they are multiplying by -7, so it is my job to turn it into a 0. Not a 0, I'm going to turn it into a 1. Adding and subtracting, turn it into a 0. Multiplying and dividing, turn it into a 1. If they're multiplying by -7, I need to divide by -7. I just did that to the Penelope side, so I'm going to come over here and do it also to the Adeline side. Then I'm going to think to myself, my rules here, division, same signs, positive. X equals 2. One more. You can look at this as division or multiplication, but the big idea here is if you're multiplying or dividing, turn it into a 1. That's the main idea here, and you've seen that come up in your homework a little bit. If I'm turning this into 1, ready? Multiplicative inverse is -7/1. Flip that thing over and then do the exact same thing over here. -7/1 is just -7, really. So what I'm doing is multiplying both sides by -7. It has to be a -7 because I want it to be a +1. 7 times 14, I don't know, 70 plus 28, so 98. You can type it in if you want to verify it, but I think it's 98. 7 times 14, 98. And it's +98 because a negative times a negative. We turned this into 1, so x equals 98. Once again, those 4 equations looked really, really similar, but they ended up with hugely different answers because we're doing different operations. Changes things a lot. Okay, so now you've done 8 examples with me. The rest of these boxes, you're not going to label as example, you're just going to label as 1 through 16, 24. 24. Let's see how many boxes we have left. 1, 2, 3, 4, 5, 6, 7, and 8. Then flip over to the back and do 9. See, I always struggle in that corner. 10, 11, 12. Got 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and we have one more row. For the rest of today, all you are doing is practicing one-step equations. Pay very close attention to, am I adding, subtracting, or am I multiplying, dividing? Should I be turning it to 0, or should I be turning it to 1? And I need to see, when you submit photos of this work, I need to see that you copied the equation and you wrote the inverse step and you got a solution before you typed it in or clicked anything on your quizzes. So you will submit a page of work for me. Make sure I can see both sides really clearly so that I can see you did all that. I copied the equation, I wrote the inverse operation, and I promise you if you do all that, you will get a lot more correct answers, first of all, but second of all, you will also be prepared to move on to more difficult equations tomorrow. And of course, if you have any questions, please ask.